Welcome to This Explainer. Today, we're taking you from a confused bystander to a highly capable amateur forecaster. You know, we've all watched a meteorologist point at that dizzying array of swirling lines and thought, how on earth do they pull a weather forecast out of that absolute chaos? Well, today, we're going to learn exactly how they do it.
At first glance, it really just looks like a massive, complex cipher, right? Just this chaotic mix of blues, reds, lines, and, well, really strange symbols. But we're going to crack this code together. By the end of our explainer today, you'll be able to look at these exact same maps and actually predict what the sky is going to do tomorrow. It's going to be awesome.
So here's our agenda for today. 1. Decoding the map. 2. High and low pressure. 3. Understanding weather fronts. 4. Clouds and precipitation. And 5. Making your actual forecast. Let's get right into it.
All right, Section 1, Decoding the Map.
Take a look at this. We've got this incredible, expansive view of Europe, totally covered in swirling weather systems that are just constantly in motion. This is the real deal, the kind of professional forecast issued by actual meteorological institutes. Now, to the untrained eye, sure, it's just a mess of pressure markers and isobars. You know, those lines connecting areas of equal pressure. But this map right here, this is our playing field. And the very first rule of the game is wrapping our heads around its absolutely massive size.
To really grasp the scale here, just look at the grid lines. A mere 10 degrees of latitude on this chart equals a staggering 1,111 kilometers. To put that into perspective, that is roughly the driving distance from Paris all the way to Berlin. And if you're looking at longitude around, say, 40 degrees north, a 10-degree span covers about 825 kilometers. So what's the takeaway here? When you spot a storm system that looks like it's just spanning a tiny section of the map, it's literally covering hundreds, if not thousands, of kilometers across an entire continent. It's huge!
Okay, moving on to Section 2, High and Low Pressure.
Now, the fundamental rule to remember, and I mean this is a true staple of your forecaster's toolkit, is exactly how wind behaves around pressure systems. Just think of the hands of a clock. So for a high air pressure area, which is marked with an H, the wind blows clockwise right around it. But for a low air pressure area marked with an L, it flows in the exact opposite direction, counterclockwise. It sounds simple, right? But this single basic principle dictates the movement of massive amounts of air right over our heads.
You can really see how the wind flows entirely differently depending on which pressure system is driving it. Forecasters will literally circle these high and low areas and draw arrows just to map out the flow. It's super helpful because you can see how the wind moves parallel to those isobars, basically swirling around the pressure centers, kind of like water circling a drain.
But of course, things get complicated. What happens when these massive swirling systems overlap? Well, conflicts arise. In these really messy middle areas, the rule of thumb is actually pretty simple. Just take the direction of the nearby dominant pressure area. And hey, if you find a spot on the map with no wind yet, just expand the influence of the closest pressure system. Though, keep in mind, in areas where little to no wind is actually blowing, drawing arrows is kind of superfluous anyway.
All right, Section 3, Understanding Weather Fronts.
When you look at the lines slicing across the map, you'll definitely notice these very distinct symbols, little half circles and little triangles. Now, these aren't just decorative flourishes. These symbols are quite literally pointing the way. They tell us exactly where the front is moving. They're basically tracking the forward march of the boundary between totally different temperature zones.
So here we see two of the main battles playing out. A warm front pushes relatively warm air forward, and that brings along lower, thicker stratus clouds. On the flip side, we have an occlusion front. Now, this happens when a fast-moving cold front actually overtakes a warm front, literally sliding right underneath it, and this brings entirely different cloud structures, like altocumulus.
Which brings us to Section 4, Clouds and Precipitation.
This sequence is honestly fascinating. It perfectly illustrates the predictable progression of clouds as a major weather system approaches. First off, you're going to see those wispy cirrus clouds high up in the sky. These guys can arrive anywhere from 0 to 150 kilometers ahead of the main system. Next, as that warm front gets closer, the sky starts to thicken up with lower stratus or nimbostratus clouds. And finally, right on the boundary of the cold front itself, boom, you get those dramatic, towering cumulonimbus clouds.
So by pairing the front type with these visual clues, you can determine exactly whether you're going to need an umbrella or sunglasses. Prior to a warm front, say at a distance of about 150 kilometers, you can generally expect drizzle or incoming rain. Underneath an occlusion front, expect rainy weather interspersed with some dry periods. But here's the cool part. If you happen to find yourself situated directly between a warm and a cold front, it's going to be fairly cloudless.
You might see just some high cirrus clouds, which means absolutely no precipitation at all.
And finally, Section 5, making your forecast.
This is where it all comes together. Professionals break down their predictions into this exact kind of grid structure for specific locations. For instance, if you were making a weather description for a city like Utrecht in the Netherlands based on all this map data, you would fill out a table just like this one. You literally need to pull together every single variable we've discussed today. Temperature, wind direction, wind strength, precipitation, and type of cloud cover, all spread over a timeline of several days. To actually fill out that table, you just follow these exact steps, layering the data one piece at a time. Step 1. Track those highs and lows and draw your clockwise or counterclockwise arrows to get your wind direction. Step 2. Look closely at the isobars to determine wind strength. Are they packed closely together? That means strong winds. Far apart? Weaker winds. Step 3. Locate your warm and occlusion fronts to map out the temperatures. And then finally, Step 4. Identify the precipitation areas and match them right up to the cloud types we just learned about. Now, before you finalize your forecast, there is an absolutely crucial pro tip you've got to remember regarding that third step. When you're looking at these fronts, remember this key quote from the source data. This does not say anything about the absolute temperature. I love that, because when we say a front is warm or cold, it only tells us if it is relatively hot or cold compared to the immediate environment around it. It definitely does not give you an exact number on the thermometer. The whole thing is relative to the clash of the air masses.
And there you have it. You now hold the power to decode the invisible forces shaping our atmosphere. You know how to track those swirling winds of high and low pressure. You can interpret the battle lines of weather fronts, and you can actually read the sky's cloudy warnings. So what does this all mean for you? Well, the next time you see a wispy cirrus cloud creeping across the horizon, don't just admire it. Ask yourself, what invisible battle is raging 100 kilometers away, and when exactly is it arriving at your doorstep? Thanks so much for joining me on this explainer, and hey, happy forecasting!